Hi children, welcome. Welcome to another chemistry class. Today we are discussing the 12th standard portion P block elements. All of you know P block elements we are discussing in 11th and 12th. In the 11th standard we are discussing group 13, 14, family and its compounds. While in this chapter, that is 12th standard P block elements, we are discussing group 15 to 18, right? That is nitrogen family, oxygen family, halogens, noble gases. So let's have a talk on a few important questions from that area. Okay, right. First question. Formation of oxide ion from oxygen atom requires first an exothermic and then endothermic reaction. You see the electron gain enthalpy first value minus 141, while the second value is highly endothermic plus 780 it comes out. The process of formation of O2 minus in gas phase is unfavorable even though O2 minus is isoelectronic with the neon. The fact is, why? Why? That is the question. All of you might have learned this topic. There is a question in the NCERT XII itself. There is a question from the NCERT exemplar book and a previous entrance exam question. And the answer is, which one? Option 3. The electron repulsion outweighs the stability gained by achieving noble gas configuration. Oxygen, you know, it is small atom. When you add one electron, okay. Not only for oxygen, for almost all elements, the second electron gain enthalpy is positive figure, endothermic, because there will be interelectronic repulsion. It is not only for oxygen. Almost all elements, the second ionization enthalpy, we can see it is endothermic in nature, which is due to the interelectronic repulsion. Okay, and the answer is third choice. Next question. Strong reducing behavior of H3PO2 is due to, because of the presence of two reducing hydrogen. Out of the three hydrogen, all of you have learned, only one hydrogen is acidic hydrogen. It is a monobasic acid, while the two other hydrogen atoms are directly connected to phosphorus, and that is a reducing hydrogen. First choice is wrong. It is not a high oxidation state. It is +1 state. Presence of 2 OH group is wrong. Presence of 1 OH group, 2 pH group. That is the correct answer. Why? Because this is the structure. This is the structure H3PO2, hypophosphorous acid or phosphinic acid. The structure is, you draw the tetrahedral situation and one PO double bond essentially required and one OH bond essentially required, and now oxygen is over, the remaining will be two hydrogen, and these two hydrogen are reducing hydrogen. The presence of reducing hydrogen makes it a good reducing acid. So these two hydrogen are the reason for that characteristics, right? Next. Third question. Why there is a high boiling point for hydrogen fluoride? That is the question. Why the hydrogen fluoride, the boiling point is very high? That is the question. Everybody know, when there is fluorine with the hydrogen, when there is oxygen with the hydrogen, when there is nitrogen with the hydrogen, the three most important high electronegative elements, maybe the molecule HF, water, ammonia, there is hydrogen bonding, and the boiling point is extremely high, abnormally high due to hydrogen bonding. Which option? Option 4. It is due to hydrogen bonding present in HF. The same scenario we will find in water molecule. The same scenario we will find in ammonia. When you compare the hydrates of group 15, 16, 17, you will find the first member behave abnormally and the boiling point is not comparable with its low molecular mass. Even though the molecular mass is low, the boiling point is high, molecular attraction is high due to the strong dipole-dipole attraction which we call it as hydrogen bonding in these cases. Okay, next. Hot concentrated sulfuric acid, moderately strong oxidizing agent, which does not show oxidizing behavior. See, carbon is oxidized to carbon dioxide and sulfuric acid is reduced to sulfur dioxide. That is that is acting as an oxidizing agent. So the reaction 1 acting as oxidizing agent. We want the reaction does not show oxidizing behavior. And the answer is second one. Here there is no oxidizing behavior. It is simply displacement of volatile acid HF from the salt. You know, sulfuric acid is a low volatile oil type acid and it can displace volatile acids from its salt solution. Like HF, HCl, HNO3 can be displaced from the corresponding salt solution by sulfuric acid. It is not a redox reaction. It is not a redox reaction and nobody undergo a change in oxidation state. While here copper is oxidized to copper sulfate, here sulfur is oxidized to sulfur dioxide. So all the other reactions indicate oxidizing character of sulfuric acid except option 2. That is the answer. Next one. Geometry and hybridization for XeF4. XeF4 contain, all of you know, XeF4 contain how much? 8 valence electrons here, 4 surrounding monovalent atoms divided by 2. You are getting 6 electron pair and that go for sp3d2 hybridization. And the geometry fall like this. You have xenon at the center and 4 fluorine on the corners of the plane, while 1 lone pair on top, 1 lone pair at bottom, and it is square planar geometry. It is square planar geometry and the answer is second choice. Square planar geometry, sp3d2 hybridization. Well known to all of you, right? 8 valence electrons from xenon, 4 surrounding monovalent atoms, 8 plus 4, 12 by 2, 6 electron pair stands for which hybridization? sp3d2, right? Next question. Wrong statement. Which one is wrong statement? SeF4, CH4 have same shape. That itself is wrong statement. That itself is wrong statement. What is the case of SeF4? What is the case of SeF4? SeF4, 6 valence electron from selenium and 4 surrounding monovalent atoms. 10 by 2 you are getting 5 means it is sp3d hybridization and the shape of the molecule will be selenium 1, 2, 3, 4, 5. And we have 4 fluorine atom and it will go for seesaw geometry. It is seesaw shape. That is AB4E type molecule, seesaw shape. What about methane? All of you know methane is tetrahedral geometry. So they don't maintain the same molecular shape. They are different shape. Methane is tetrahedral and SeF4 like SF4 is seesaw in shape and that statement itself is wrong. What about the other one? I3 plus has bent geometry. I3 plus has bent geometry. You see, I3 plus means I2 plus will go for 7 valence electron from iodine, 2 surrounding monovalent atom, 7 plus 2, 9, minus 1, you are getting 8 by 2, 4. That means sp3 hybridization. And the geometry will be like this, bend shape. It will be bend shape. It will be bend shape with a lone pair. I mean, with a positive charge on the central iodine. Right? Bend shape. sp3 hybridization, angular shape. Ab2E2 type molecule. pH5, BiCl5 does not exist. All of you know that. pH5 cannot exist. pH3 can. BiCl5 cannot exist. Only identified compound is BiF5. The plus 5 oxidation state for bismuth is not comfortable and is observed only with the fluorine. You have learned. There is P-pi D-pi bond in SO2. Definitely SO2 a bend shape. There is multiple bond coming, and the multiple bond involves p orbital of oxygen with the d orbital of sulfur. There is P-pi D-pi bonding. Okay, next. So all the statements are true except the first one. Isoelectronic and isostructural. Isoelectronic and isostructural. See, first molecule BeCl2, linear in shape. XEF2, linear in shape. They are isostructural, but it's not isoelectronic. Beryllium, a low member atom. Xenon is a high member atom. So it is not isoelectronic. What about TeI2? TeI2, XEF2. XEF2 is linear. TeI2 is bend shape. Tellurium, oxygen family. Tellurium, oxygen family. 6 valence electron, 6 plus 2. 8 electron, 4 pair. sp3 hybridization. So TeI2 is sp3 hybridization and angular shape Ab2E2 type. This is TeI2. TeI2, 6 valence electron surrounding monovalent atom 2 divided by 2, you are getting 4 means sp3 hybridization, and it will go for 1, 2. 1 iodine here and 2 lone pairs. 2 lone pairs. It is Ab2E2 type molecule, angular molecule, while XEF2 is linear in shape. It will go for sp3 dehybridization and linear geometry. Okay, XEF2, verify. XEF2, 8 electrons with xenon, 2 electrons from fluorine divided by 2, you are getting 10 by 2, 5 means sp3 dehybridization. What is the molecular geometry? Xenon 1, 2, 3, 4, 5. Only 2 fluorine. 1 fluorine will be here, 1 fluorine will be here, and lone pair here. It is a linear molecule. So they are not isostructural. What about third option? That is the answer. They are isoelectronic and they are isostructural. Look at IBr2 minus. IBr2 minus. Iodine 7 valence electron surrounding monovalent atoms 2 and 1 charge. So it is 10 by 2, you will get 5, and it is sp3 dehybridization. And it will go for iodine 1, 2, 3, 4, 5. And you have 2 bromine like this with the 3 lone pairs. And it is overall minus charge. It is a linear molecule. It is a linear molecule Ab2E3 type. Ab2E3 type molecule. So both that molecules ions are isoelectronic as well as same structure. So this is linear sp3d, this is linear sp3d. They are isostructural and isoelectronic. Okay, is it clear? Next, what will be IF3 character? IF3 will be T shape. IF3 will be T shape. sp3d hybridization, T shape. Okay, next. So third choice is the answer. Bond angle 120 degree. This is somewhat less than 90 degree. That is T shape, less than 90 degree due to lone pair. NCl3 in the range of ammonia bond angle. And yeah, here we have the answer, direct answer there, BCl3. That is a regular geometry, BCl3, sp2 hybridization and regular geometry, trigonal planar with a bond angle 120 degree. BCl3 is the answer, sp2 hybridization. BCl3 go for sp2 hybridization, trigonal planar. sp2 and planar with a bond angle 120 degree. That is the answer. Straight down, a very famous molecule. Next one. Which contain SS bond? Which contain SS bond? S2O7 2 minus. S2O7 2 minus. S2O7 2 minus is S2 S2 O7 2 minus 6 oxygen 7 oxygen. So there is no SS bond. There is no SS bond in S2O7 2 minus. It is oleum, salt of oleum. There is no SS bond. Therefore, first choice is out. What about S4O6 2 minus? S4O6 2 minus. S4O6 2 minus is yes. See, you don't have to by heart the structures. You can try with a logical approach. Now, how many oxygen over? S4O6 is over. Now, there are two S and it will go for like this. Per sulfide linkage. There is SS linkage. There is SS linkage. Isn't it? So, that can be the answer. Now, what about the next one? S2O3. S2O3. This is S2O3. S2O3 2 minus. This is S2O3 2 minus. There is SS linkage. There is SS linkage, and that is the answer. Traditionally, this bond is represented by the coordinate bond, while modern review says that it is a multiple bond. So there is SS linkage in both the species, and that is the answer. Option 2 is the correct answer. Option 2 is the correct answer. Any other species we need to have a look at? You please verify the structure of S2O8 per disulfate anion and try find out there is no SS linkage. Rather it is peroxy linkage. Verify. Okay. Second choice is the correct answer. Yes. Oh, structures are given. Next. Correct order of nitrogen compounds in its decreasing order of oxidation state means high to low. High to low. Nitric acid is plus 5. Nitric acid plus 5 minus 3. So that is not in the correct order. Correct order is third choice. Third choice. Here nitrogen plus 5 state. Here nitrogen plus 2 state. Here nitrogen elementary state 0. Here nitrogen minus 3 state. So that is the decreasing order. That is the decreasing order. Nitric acid, nitrogen, plus 5 state. All of you know. NO, easy to find out, plus 2 state. N2, elementary state is 0. And in ammonia and derivatives, it is minus 3. Okay. Yes. Next. Not true for halogens. Not true for halogens. All but fluorine show positive oxidation state. True. All are oxidizing agents. True. All form monobasic acids, oxyacids. Somewhat true, except in the case of fluorine. Fluorine does not form oxoacids. For the namesake, it is forming one oxoacid, HOF. That too can be isolated under specific conditions. Chlorine has highest electron gain enthalpy. Oh, so this will be the answer. This will be the answer. Because this is true, this is true, this is true. Here it is not completely true. Because we know fluorine does not permit to give all oxoacids of character. And all oxoacids are given by chlorine. And somewhat by bromine iodine, but not fluorine. Fluorine, for the namesake, it forms one oxoacid, and that is HOF. That too under specific, isolatable, low temperature conditions. Okay? Yes. So that will be the incorrect statement. Column matching. XeF4 square planar, already we have seen. XeF4 square planar A2. A2 means these choices cancelled. B3, നോക്കിയിട്ട് കാര്യമില്ല. C, what about C? XeOF4. 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 Xenon 8 valence electron surrounding monovalent atoms 4 divided by 2, you are getting 6. That is sp3d2 hybridization. sp3d2 hybridization, and the shape of the molecule will be xenon at center. And you have like this 4 fluorine atom in the corner of the plane and 1 oxygen atom, 1 lone pair. That is square pyramidal. That is square pyramidal. XeF4 go for square pyramidal. XeF4 will go for square pyramidal. So C with 4. C with 4. So the answer is first choice. A with 2 square planar. B with 3 XeF6 distorted octahedral. Yes, XeF6 8 valence electron plus 6 how much? 14. It is 7. sp3d3 hybridization. It will go for sp3d3 hybridization. sp3d3 hybridization, and the molecule is AB6E type. Since there is a lone pair, it is not going to be regular octahedral, it is going to be distorted octahedral. Okay, it is going to be distorted octahedral. What about XeO3? XeO3 is pyramidal because it is sp3 hybridization. It will go for sp3 hybridization. And the molecule is of the type AB3E type. sp3, AB3E type. It is pyramidal in shape. Pyramidal in shape. Therefore, first choice is the correct answer. This is the correct answer. Next question. Match the following. Pure nitrogen. Pure nitrogen will match with this one. Pure, very pure nitrogen produced by the thermal decomposition of metal azides. Metal azides. Metal azides on decomposing, you get very pure nitrogen, which is utilized in safety airbags in automobiles. You might have heard about. Now, Haber process ammonia. So 1 with 4. 1 with 4. A with 4. You get your answer. Third choice. Third choice is the answer. B3, Haber process. Yes. C2, contact process. Yes. D1, Dickens process. Yes. All are the referred reactions in the NCERT. But looking at the first choice itself, you are able to confirm your answer as option 3. Right? Next question. correct stability order, stability of hydrides decreases down the group, stability of hydrides decreases down the group, bond enthalpy decreases down the group, stability decreases down the group, dissociation constant decreases, decreases down the group, dissociation constant will increase down the group, isn't it? Will increase down the group. Dissociation constant will increase down the group. Ka value increases down the group. Acidic character pKa value decreases down the group. Acidic character increases down the group. So regarding hydrides, keep it in your mind. Thermal stability decreases down the group. Bond angle decreases down the group. Bond length increases down the group. Stability decreases down the group. Acidic character decreases down the group. Reducing property increases down the group. Right? I think I told you acidic character increases down the group because pKa decreases. Ka increases, pKa decreases. So all these you have to keep it in your mind. Regarding hydrides, here it is asked for thermal stability. Thermal stability will decrease down the group. Thermal stability will decrease down the group. So this is the answer. H2O maximum, oxygen, sulfur, selenium, tellurium, polonium. So down the group, thermal stability decreases as the size of central atom increases, bond length increases, bond strength decreases, dissociation enthalpy decreases, right? Next, don't think that it is only for oxygen family. It is a common point for hydrides. Okay, next. Incorrect statement about PCl5. Two axial bond make 180 degree. Yes, that is a correct statement. Axial bonds are longer than equatorial. Yes, equatorial bond angle is 120. Axial making 90 with equatorial, so bond length increases. It is non-reactive. That is a wrong statement and that is the answer. Third one is the answer. It is not non-reactive, it is active, particularly due to that long bond. Due to long axial bond, it is more reactive. 3 equatorial, that too is a true statement. So all the statements are true except option 3. Okay, next. Which contain OO linkage? Which contain OO linkage? This is what the molecule which I asked you to check earlier. And it is peroxodisulfuric acid. There is OO linkage. Peroxodisulfuric acid. There is OO linkage. This is peroxodisulfuric acid and which contain an OO linkage. There is OO linkage. Peroxodisulfuric acid. Peroxodisulfuric acid. And the answer is second choice. You may kindly verify the other options also whether there is OO linkage present or not. There is not. Okay. Next question. Next question. When blue litmus paper dipped into a solution of hypochlorous acid, it first turns red and then decolorizes by HOCl. Here HOCl act as. Option B. Option B. Acid and bleaching agent. Because it is acid, blue litmus turned red. Because it is acid, blue litmus turned red. Because it is a bleaching agent, that red color finally disappears. Bleached. Hope it is clear. Hope it is clear. See, this is an acid. Therefore, blue litmus turned red. Hope it is clear. Now, this is also liberating nascent oxygen. So it acts as a bleaching agent. So blue turned red, okay. After some time that red is decolorized. It is bleached away because it is a bleaching agent also. That's it. And the bleaching action is due to liberation of nascent oxygen. Next. 1 mole H3PO2 will neutralize X mole NaOH, Y mole calcium hydroxide, Z mole aluminum hydroxide. Assuming strong electrolyte. You know this is a monobasic acid. Monobasic acid with the monoacidic base. Monobasic acid with the monoacidic base. So H3PO2 is a monobasic acid. And NaOH is monoacidic. So they react 1:1 ratio. So here it is given X. X is 1 because 1 mole with the 1 mole. While calcium hydroxide is a diacidic base. So how much they will react? They will react 1:half. While aluminum hydroxide, even though amphoteric, it is tribasic in nature. Tribasic in nature. So how much they react? They react 1:1 ratio. They react 1/2 ratio. They react 1/3 ratio. So what is the quantity of ratio between these three? 1:1/2 1:2 1/3. What is the answer? Option C. 1/2 1/3 means 632. 1/2 1/3 means 632. So 1 mole hypophosphorus acid will completely react with 1 mole NaOH. Monoacidic, monobasic acid, monoacidic base. Now this is monobasic acid. Calcium hydroxide is dibasic. So 1/2. Aluminum hydroxide is triacidic. So 1 with 1/3. So NaOH is 1. Calcium hydroxide is half. Aluminum hydroxide is 1/3. 1/2, 1/3. What is the ratio? What is the ratio? 632. 632. Next question. The basicity of hypophosphorus acid, phosphoric acid. Very simple question. Oh, and pyrophosphoric acid. This is 1, this is 2, and this is 3. So 1, 2, 3. 1, 2, 3. And this should be the answer. What about pyrophosphoric acid? Is it 4? We will verify. Is it 4? Phosphorus. 1, 2, 3, 4. 1, 2, 3, 4. And essential requirement is a PO double bond and a POH bond. Now how many oxygen? There is more hydrogen and oxygen. So you can give one more OH. So now hydrogen is over, oxygen 6 and one more oxygen. So it is over. This is the structure, pyrophosphoric acid. And it is tetrabasic. It is tetrabasic. Have a look at this. Basicity number 1, basicity number 2, basicity number 3, basicity number 4. It is tetrabasic. So hypophosphorus acid, monobasic acid. Phosphorus acid, dibasic acid. Phosphoric acid, tribasic acid. That thing, all of you, well known to all of you. Pyrophosphoric acid, tetrabasic acid. It is 1, 2, 3, 4 like that. Okay, fine. Next question. The compound that does not exist, NF5 can never exist. Maximum covalency of nitrogen is 5. So this can never exist. BiCl5 does not exist. Already we have commented. PF5 can exist. Answer is option A and B. Option A and B. Okay. Next. Direct question only. How many P.O.P bonds are there in HPO3 thrice? That is cyclotrimethaphosphoric acid. That is cyclotrimethaphosphoric acid. You may be aware of the structure. HPO3 thrice. This is nothing but cyclotrimethaphosphoric acid. How is the structure? How is the structure? Yes, it is oxygen, phosphorus, oxygen, phosphorus, oxygen, phosphorus. Give it like this. A hexagonal ring type, actually it is 3D, a hexagonal ring type structure. And now, what are the essential requirements? A phosphorus should contain a PO double bond and a POH bond. That is essentially required. So, a PO double bond and a POH bond. A PO double bond and a POH bond. This is the structure of cyclotrimethaphosphoric acid. And what was the question? How many POP? POP, 1 POP, 2 POP, 3. There are 3 POP. There are 3 POP. Answer is option 3. Answer is option C, 3. Right? Next. Dilute and concentrated NaOH react with chlorine to form respectively. You might have learned the reaction in the NCERT. With the dilute and concentrated NaOH, how chlorine react. Chlorine react with the dilute NaOH giving NaClO and NaCl with water. While chlorine with the concentrated NaOH, you get NaClO3 with NaCl and water. You know the reaction. And the answer is option D only. Option D, isn't it? NaClO plus NaClO3. Option D. And this is the reaction. Chlorine with the dilute NaOH. You are getting this, this, this. So this is common point. This is common point. The difference comes over here. So with the dilute NaOH, you will be getting sodium hypochlorite, and with the concentrated NaOH, you will be getting sodium chlorate. Very important reaction. Okay. Next. A substance on treatment with the dilute sulfuric acid liberates a colorless gas which produces turbidity with baryta water and turns acidified dichromate solution green. These reactions indicate the presence of a substance on treatment with the dilute sulfuric acid liberates a colorless gas. Option C, SO3 with the dilute sulfuric acid, you will get SO2 gas liberated. SO2 gas liberated. Imagine this is treated with dilute sulfuric acid. All the reactions are given in the textbook. SO3 2 minus interacting with the dilute sulfuric acid, you will get SO2 gas liberated. That is given as a method of preparation of SO2 in the textbook. You can find out. Now, what is second one? Turbidity with the baryta water. This with the baryta water means barium hydroxide. See, the reaction of SO2 with alkali is similar to carbon dioxide. The reaction of SO2 with alkali similar to carbon dioxide. You will get a white turbidity. You will get milkiness. You will get milkiness due to the formation of barium sulfate. Barium sulfite. Okay, there will be turbidity. The reaction is similar to carbon dioxide. Now, the same one reacting with the potassium dichromate. Isn't it potassium dichromate? Yes. K2Cr2O7 in acid medium. You will get green colored chromic sulfate. You will get green colored chromic sulfate. So all the reactions are pertaining to one species, and the species is nothing but SO3 2 minus, and the answer is option C. That is the species. Yeah, all the reactions are given also. Okay, fine. Next. The set with the correct order of acidity. Set with the correct order of acidity. First choice. Here it is +1 state. Here it is +3 state. Here it is +5 state. Here it is +7 state. The acidic strength increases with the increase in oxidation number. The order of acidic strength will be in the increasing order of oxidation number. You have learned. So it is hypochlorous acid minimum, then chlorous acid, chloric acid, and a stronger one is perchloric acid. Okay. Next. XeF4 with NAF. XeF4 with NAF. See, XeF4 can act as fluorine donor and fluorine acceptor. If it is interacting with the PF5, it will act as a fluorine donor. If it is interacting with alkali metal fluoride, it will act as a fluorine acceptor. It will accept a fluorine. Which one is the answer? Na will become there as Na plus only, and XeF6 will become XeF7. Yes, option C is the correct answer. Option C is the correct answer. It acts as a fluorine acceptor. Okay. Yes. The hydrolysis product of BrF5 is. Hydrolysis product of BrF5 is. You might have learned in the class how to find out the answer. BrF5, when treated with water, the smaller halogen will be converted to HF. The smaller halogen will be converted to HF, while the bigger halogen, according to its oxidation state. See, it's very simple to understand. The oxidation state is -1 and it remained -1. Okay, and here it is +5, so it will be converted to +5 acid. What is the +5 acid? HbRO3. HbRO3. So during hydrolysis, the oxidation state remain unchanged. Keep that in mind. You will get your answer. So fluorine minus, you will get HF. H plus F minus, you are getting HF. Here it is +5, it will go for HbRO3, where bromine is +5 state. So the answer is option A, HF, and option C, A and C. D is the correct answer. A and C, D is the correct answer. You get this and you get this. Option D is the correct answer. Try more examples. Okay. Next. Hydrolysis of 1 mole of peroxodisulfuric acid produces. 1 mole of peroxodisulfuric acid will produce. This is peroxodisulfuric acid. Already we have seen the structure. This is peroxodisulfuric acid. Suppose it is undergoing hydrolysis. You can understand in two ways. First step hydrolysis, imagine. The product can be, imagine it is breaking here. This is minus and this is plus. Here you will get H plus and here you will get OH minus, and this part of the molecule will be converted to sulfuric acid, H2SO4, while this part of the molecule will be converted to peroxomonosulfuric acid, H2SO5. That is one step hydrolysis. Suppose it is undergoing both step hydrolysis, imagine. Suppose it is undergoing both step hydrolysis. What can happen? The point is, again, you see, it will break here also. So this is minus and this is plus. Here you will get H plus. Here it is OH minus. And now this part of the molecule will also be converted to sulfuric acid, while the central part of the system will be converted to H2O2. So there are two possibilities. half hydrolysis, you get 1 mole sulfuric acid and 1 mole H2SO5. This is one chance. Second chance is complete hydrolysis. You get 2 mole sulfuric acid and 1 mole H2O2. These are the possibility. So 2 mole sulfuric acid, yes, that can be. 2 mole peroxomonosulfuric acid. This is wrong. This can be. 1 mole sulfuric acid and 1 mole peroxomonosulfuric acid. This can be. This can be more precise than the first choice. 1 mole each of sulfuric acid, peroxomonosulfuric acid, hydrogen peroxide. No, that cannot be. So I will go with the option C, the most correct answer. Suppose there is half hydrolysis. Suppose there is half hydrolysis, you can get 1 mole sulfuric acid and 1 mole peroxomonosulfuric acid. Suppose it is complete hydrolysis, it can be 2 mole sulfuric acid and 1 mole hydrogen peroxide. Such a choice is not available, so I am selecting the most appropriate choice, option C. Going with the first step hydrolysis, option C. Okay. The bond dissociation enthalpy is maximum 4. Bond dissociation enthalpy order, all of you know. What is the order? Cl2 maximum, then Br2. Fluorine comes in the third place only. Fluorine comes in the third place only due to small size and interelectronic repulsion. Maximum chlorine, then bromine, then fluorine. So keep specially in that in your mind. Regarding electron gain enthalpy, fluorine maximum, fluorine next, fluorine maximum, then fluorine, then bromine, then iodine. This is for electron gain enthalpy. While bond enthalpy, this is the order. Bond enthalpy order is that, and fluorine comes only in the third position. Our point is maximum. It is no doubt chlorine the answer. Chlorine is the answer. Option B. Right? After chlorine, then bromine, then fluorine, then iodine. Next. With excess ammonia, chlorine forms. With excess of, that's another important reaction. With excess ammonia and chlorine, what do you get? With excess chlorine and ammonia, what do you get? A very important reaction you need to note down. You see, with excess ammonia, you will be getting ammonium chloride and N2 gas, while with excess chlorine, you will be getting NCl3, yellow oily liquid with pungent odor. And that is explosive also, highly explosive also. NCl3 with the 6HCl. Here is asked for excess ammonia, so it will be ammonium chloride and nitrogen. Ammonium chloride, only one choice given, option B. Ammonium chloride and nitrogen. While with excess chlorine, the reaction has to be handled carefully because the product obtained is explosive product. NCl3, yellow oily liquid with a pungent odor. Right? Next. In analogy to O2PTF6, a compound N2PTF6 will not be formed because the ionization energy of, see, compared to this one, we were able to get a product. Compared to this one, we were able to get a V means who prepared, you know the history, Bartlett, Neil Bartlett prepared a red colored product, this one, and he thought of preparing a product XIPTF6. And what was his logic? The ionization enthalpy of xenon and oxygen was nearly same. The ionization enthalpy of dioxygen and xenon, he observed nearly same. And when he prepared a red colored compound like this, he thought of preparing such a compound and he was succeeded. Now the question is, why can't you prepare a similar molecule N2PTF6? See, this and this ionization enthalpy is nearer, while this ionization enthalpy of N2 gas, it is very high because it is a stable molecule, inert molecule. So you can't have a comparison like that. So N2PtF6 cannot be prepared because the ionization enthalpy of N2 gas is much higher than O2 gas. Option A is the correct answer. And that was the last question from the concerned chapter. We were dealing with the group 15, 16, 17, 18. P block element of the 12th standard topic. We'll catch you with another class, another chapter, another few beautiful questions. Till then, bye. Take care. See you.